Morning class. Here as Group 2 representative, as we are assigned to discuss about KNN, which means K-nearest neighbor algorithm. KNN, K-nearest neighbor algorithm, is a supervised machine learning algorithm generally used for classification, but can also be used for regression tasks. Means it can do two things: for classification and regression tasks. It works by finding the K closest data points neighbors to a given input and makes a prediction based on the majority class for classifications, or the average value for regressions. Since KNN makes no assumptions about the underlying data distribution, it makes it non-parametric or instant-based learning method. Here is an example. For example, the new point is classified category to become most of the closest neighbors are blue squares. Here it is a new point classified as category 2. So KNN assigns the category based on the majority of nearby points. The red diamonds represent category 1, as blue squares represent category 2. The new data point checks its closest neighbors. Suppose since the majority of its closest neighbors are blue squares, here, KNN predicts the new data point belongs to category 2, as it's one of the closest data. KNN works by using proximity and majority voting to make predictions. So as here the closest data was category 2, it predicts it belongs to the blue neighbors. So you can ask yourself, what is K in K nearest neighbor? K in the nearest neighbors algorithm, K is just a number that tells algorithms how many nearby points or neighbors to look at when it makes decisions. Example: imagine you are deciding which fluid is based on its shape and size. You compare it to fluids you already know. If K equals to 3, the algorithm will look at the 3 closest fluids to the new one. If 2 of those fluids are apples and 1 is banana, the algorithm says the new fluid is an apple because most of its neighbors are apples. As we have seen, K-nearest neighbor use proximity. Step by step, how to use KNN. Step 1 is to collect and prepare the data set. Step 2, split your data. Divide your data into training data or testing data. Step 3, you choose the value of K. And step 4, to calculate the distance. KNN measures how close the new data point is to others using distance formulas when find the nearest neighbors. And step 5 is to make the predictions. And the last step is to evaluate the model. And here is the applications of KNN. Recommendation systems suggest items like movies or products by finding users with similar preferences. It also applied in spam detection. It identifies spam emails by comparing new emails to non-spam or non-spam examples. It also applied in customer segmentation and also in speech recognition by matching The next is advantages and disadvantages of KNN. The advantages is it is simple to use, easy to understand and implement. The second advantage is no training test. No need to train as it just stores the data and uses it during prediction. Another is few parameters. Only needs to set the number of neighbors and distance methods. Another is it's versatile. Works for both classification and regression problems. For the disadvantages, it's slow with large data. Needs to compare every column during prediction, which makes it slow with large data. Struggles with many features. Accuracy drops when data has too many features. Can overfit. It can overfit especially when data is high dimensional or not trained. Thank you. That is the end of our presentation. If there's any problem, we can ask.
No problem. Thank you.
Thank you. Thank you.